Hi everyone, welcome to 8.4. 8.4 is where we're going to actually talk about pH, and the pH scale is how we are going to measure how acidic or how basic a solution is. Rain is naturally acidic, okay, and so if 7 is neutral, then the pH of rain is about 5.6, so it's a little bit acidic. It's not anything that's gonna damage us too much in naturally, okay, because you're going to have carbon dioxide in the air combining with water when it rains, and it's going to be that weak carbonic acid. And remember that the carbonic acid, when it combines with water, forms the hydronium ion and the bicarbonate ion. So that's what's going on when it naturally rains, because carbon dioxide is found in the atmosphere. The pH of a solution is going to tell us how acidic that solution is, and it's going to have values ranging from 0 to 14. It's acidic if it's less than 7, it's neutral if it's exactly 7, and it's basic if it's larger than 7 or greater than 7. So just to give you kind of a place to go from, you've got the neutrals, which are going to be your water. Drinking water is a little bit, 7.2, but really that's not that much. Your blood is about 7.4, so that's pretty neutral. Coffee is about 5, so that's acidic, okay, because remember, the lower the number, the more acidic it is. The higher the number, the more basic it is. And if you think about, the stronger it gets, the farther away from 7, farther away from neutral it gets. So 4 is going to be more acidic than 5. 0 is as acidic as you can get, a pH of 0. A pH of 14, which is as far away from the 7 as we're going to be able to get, is going to be very basic. So that's going to be the most basic. So try to identify each solution as acidic, basic, or neutral without looking. HCl with a pH of 1.5. Is that acidic, basic, or neutral? Try these out and let's see how you do. Alright, how'd you do? Well, if you did it without looking, one thing that you may have had to do is look at the hydronium ion concentration. Remember that neutral is 1 times 10 to the minus 7 molar. Okay, so if it's 1 times 10 to the minus 8, is that acidic or basic? It's basic. And I'm going to show you a little trick for these as well. Same thing with these two guys. Is if the hydroxide is 10, what's the hydronium? Around 2, around minus 2, right? If the hydronium is 5 times 10 to the minus 12, then that's going to be a base, because that number is greater than the minus 7. Unfortunately, in some parts of our country and also Europe and other places, we use a lot of fossil fuels, and when we burn coal, coal also contains sulfur in it, and it depends on how clean it is. The higher grades are much more pure. But since you have coal in there and you're burning it, what you're going to be doing is producing SO2, which is sulfite or sulfur dihydrogen, and SO3 gases. Now, these gases are going to react with moisture in the air, and they're going to actually, just like if we were doing a reaction in the beaker, they're going to produce an acid. And in the case of sulfate with water, what are we going to produce? Sulfuric acid. And if you look back on your chart, you're going to remember that that's a strong acid. So instead of the lovely little carbonic acid coming down, we're going to be raining down sulfuric acid. And when you add sulfuric acid to nature, it is going to lower the pH of our streams and our lakes. And when the pH of the lakes and streams gets below 4.5 to 5, and that's pretty low, right? Most fish and plant life will die. Trees and forests are also damaged as the acid rain breaks down the leaves and interferes with photosynthesis. So these are some of the Eastern European. Notice the defoliation of these trees and how bad they look. This is because the acid rain is coming in and from some of the coal plants and then raining down on this area. So it's up to us to try to take a stand on these things, and we try to give you real life applications of what we're studying, and acid rain is definitely something that we need to look at. What pH stands for is the P stands for the negative log, and the H is of the hydronium ion concentration. Okay, and it's just shorthand. Some people just say that it's the H plus. Okay, we know it's really the hydronium, but sometimes chemists are lazy, so they just write it like that. So what this tells us is, and you're going to love this, that if you have a hydronium ion concentration of 1 × 10⁻⁴, if you put that in your calculator and you do negative log of 1 × 10⁻⁴, you're going to get 4. So if your concentration is 1 × 10⁻⁴, your pH is going to be 4. If the hydronium ion concentration is 1 × 10⁻⁷, your pH is going to be, wait for it, 7. That's right. So pH is going to be whatever that exponent is, but it's going to be not the negative, but the positive number, because you're taking the negative log of that. So when you express the log values, as I said, you're going to get, if it's a 1 here, it's going to be that exact number. If it is a larger number here, then you're going to be close to this number. Does that make sense? So what you do is, when you have something other than 1 times your exponent, then you're going to put that, you're going to have to do that calculation, the negative log of this number, to get this. But if it's, here's a little trick for you. If that number right here, okay, if it's less than 5, then the first number of your pH is going to be less than whatever your exponent is. Okay, so like in the case of this one, what I'm saying is, if this number is greater than 5, okay, so it's greater than 5 and it's a -6, then the first number on your pH is going to be a 5. If this one is 2.4, that's less than 5, so the first number of your pH is going to be 7. Does that make sense? So you can kind of get a ballpark of what it is, but to get the actual number with the decimal points, you're going to have to do that negative log of 2.4 times 10 to the -8 and do that calculation in your calculator, and that'll give you that 7.62. So the guide to calculating pH of solutions is, you enter the hydronium ion concentration, you press the log key and then the sign, and usually on the TI-83s you've got like this little thing at the bottom that changes the sign for you, and adjust your significant figures on the right side of the decimal to equal the significant figures of whatever your coefficient is. Okay? So find the pH of a solution with hydronium ion concentration of 1 × 10 to the -3. Okay, well, with that one, do we have to calculate it? No, because we know that 1 × 10 to the -3, this one's a 1, so we know the pH is going to be what? 3, that's right. But just for practice, enter the 1 × 10 to the -3. And how you do that, how I do it, is I press 1, and then there should be a key on your calculator that says EE. Now on the TI you have to do second, and then the EE is above. I can't remember which one it is exactly. I'm not looking at it, but find that EE and then whatever your exponent is, okay, and then change the sign. Okay, so what you're going to do is you're going to press 1 EE minus 3, and then that's how you're going to do this part of it. So you're going to press the log key and change the sign, and then put in 1 EE minus 3. Okay? And when you do that, you should get 3. So make sure, and then of course you want to do your significant figures. Okay? Just try that out, because that's the best way to know if you're putting it in the calculator correctly or not. If you do the 1 times 10 instead of doing 1 EE, sometimes it'll throw you off by a factor of 10. So I just strongly suggest you use the EE. So if you need to go back and look at that again and practice that, do that until you get it correctly, and then you'll be able to do these. So if you've practiced those, if you want to calculate this one for practice again, but most of us now, we understand that if we have 1 times 10 minus 5, we already know the pH, don't we? And there's the solution steps. If you want to look at those, you also have them obviously on your handout. The hydronium ion concentration of tomato juice is 2 times 10 to the minus 4 molar. What is the pH of that solution? You already know what the first number on that's going to be. So if you look at your choices, you probably could figure that out without even doing a calculation. Because why? Because that is less than 5. And here are our steps. Okay, so remember that when you're looking at the concentration of hydronium ion, because they always have to equal minus 14. So minus 1 and minus 13, minus 4, minus 10. So what that tells us is, as this goes up, this goes down. Okay, as hydronium goes up, hydroxide goes down. So we've already looked at that. Okay, so when we want to look at, if we know the pH of something, we can also calculate what the hydronium ion concentration is. So on the calculator, if you put in your pH value, in this case we're doing a simple one, so you can definitely know you got the right answer or not. You enter the 3, and then you change the sign to the minus 3. Then you use the 10 to the x. Okay, and so you do minus 3 and then 10 to the x, and it should give you 1 times 10 to the minus 3. On your calculator, it will say 1e, or EE, minus 3. So what that means in calculator language is 1 times 10 to the minus 3. So that's why I have you do it with the EE. And like I said, some calculators have an E, some say EE. Okay? So that tells you that you're correct. Alright, so let's try some of these. The hydronium ion of a solution with a pH of 10. Okay, so what would the concentration be? So just go ahead and try to calculate it, just so you can see if you've got this or not. And sometimes it's trial and error if you have a different calculator from the TI 83 or 84. Alright, or you may know what this first one is. Now, what is the hydroxide ion concentration of a solution with a pH of 2? This one you have to do one more step. If the pH is 2, what is the pOH? Well, it's going to be 14 minus 2. It's going to be 12. How do I know that? Because they got to equal 14. This is the pH. So the pOH give me that. If I know that, I do the same calculation with the 12 as I did with the 10, and then I'll be able to calculate what the hydroxide ion concentration is. Okay, so in the first one, it was 1 times 10 to the minus 10. The second one, 1 times 10 to the minus 12. And that's the end of 8.4. Hope you enjoyed it. If you need to go back, obviously you can go back. You can slow me down, whatever you need to do. Speed me up. Stop listening to me if you're sick of me by now. But I will see you for 8.5.